Unit 6, Polygons in Motion, Preview Video 6.7, Part 1, Coordinate Proofs. Preview Video 6.7, Part 1, Coordinate Proofs. The main emphasis for this particular lesson is this simple truth. Math has meaning. Math does not just simply shove numbers around just for the sake of your good health. Mathematics communicate the interaction of the world around you, whether it's the physical interactions of motion or the invisible interactions of subatomic particles. Either way, mathematics communicates meaning. For the next two lessons, we're going to be talking about the meaning of polygons on the coordinate plane, and we're going to be using the language of the math of midpoint, slope, and distance. So the slope equation shows how a line tilts. And if it's parallel lines, then the slopes are equal. Slope equals slope. If it's perpendicular lines like here, the slopes multiply to -1. In other words, they are inverse reciprocal. A midpoint equation shows if something's being bisected or has a common midpoint. Midpoint equation, add the x's, divide by 2, add the y's, divide by 2. That's simply the template. So if I wanted to prove that this point is a midpoint of this segment, I would add the x's, whatever they would be, and divide by 2, and I would add the y's and divide by 2 to check to see if that premise was true. The distance equation shows comparative lengths. It can show that two lengths are equal or in measure or congruent. So if I had a segment here and let's say some random segment over here, and I want to prove that they are congruent in length, I'd be using the distance equation. And that would be the distance equation template. So we're going to be doing 3 different proofs, mathematically proving something. Here, we are given a quadrilateral. And we are told that point A is at -1, 5, B is at 3, 3, C is at 6, -4, and D is at 2, -2. We want to prove that this is a parallelogram. Remember, OCD. First quality of a parallelogram is the fact that opposite sides are parallel. So we're going to prove this is a parallelogram by showing opposite sides are parallel. Question is, how do we show parallel? We are going to use slope. So we're going to find the slope of AB and the slope of DC. And then we're going to find the slope of AD and the slope of BC. Here's your templates. Y minus y over x minus x. So y minus y, 5 minus 3, negative 1 minus 3. This is going to be 2 over negative 4. dc, y minus y, that's going to be negative 2 minus negative 4, x minus x, 2 minus 6. And that's going to be positive 2 over negative 4. So you just mathematically prove that the opposite sides are parallel. Coming over here to AD, y minus y, that's 5 and negative 2, negative 1 and 2, 3, negative 4, 3, 6, 7 over negative 3, 7 over negative 3. So we have just proven those sides are parallel. So now you do your write-up. Math, meaning, punchline. Math, meaning, punchline. Make sure, so each of these is at least 3 sentences. I'm going to bullet to make it easy. So we know that AB slope is 2 over negative 4, DC 2 over negative 4, AD 7 over negative 3, BC 7 over negative 3. There's your math. Meaning, since slope equals slope, AB is parallel to DC, AD is parallel to BC. Math, the meaning of the math is parallel, therefore the punchline is this. Therefore, since opposite sides are parallel, then ABCD is a parallelogram. Math, meaning punchline. Our punchline was proving that ABCD is a parallelogram. Mathematically, we have proven that it is a parallelogram. Wait a minute, same image. Now what? We're given the exact same image because I want you to see that there's more than one way to do all of these. We have A is at negative 1 and 5. B is at 3, 3. C is at 6, negative 4. And D is at 2, negative 2. We're again going to prove it's a parallelogram, but this time we're going to prove it by showing that the diagonals bisect. Because in OCD, if the diagonals bisect each other, let's draw and come really close here. If the diagonals bisect, so if we draw in the diagonal, AC and the diagonal BD, if they bisect each other, which means the midpoint going both ways is the same, then that must be a parallelogram. So the way we're going to prove that is we're going to be doing the midpoint of A to C, AC midpoint, that's one diagonal, and the midpoint of D to B. Add add the x's, divide by 2, add the y's, divide by 2. So for AC, my x's are -1, +6, 5 and -4. For DB, my x's is 2 and 3, -2 and 3. There's my midpoint for AC. You can see the midpoint is the same. I know a lot of you, the fractions make you a little nervous, so just to change that, this is 5/2 is 2.5, 1/2. If this was graphed accurately, come over here. If it was graphed accurately, take a close look. So we're going to go over 2.5. So 1, 2, in a half and up a half. Lo and behold, 2.5 and 1/2 is the midpoint going both ways. So math, meaning, punchline. Here's the math. There's your math. Meaning, the diagonals must bisect each other because the midpoint is the same both ways. Third, finally, ABCD is a parallelogram because diagonals bisect each other. Math, meaning, punchline. So this is your page. What you're going to do is you're given the exact same parallelogram. You're going to prove it's a parallelogram, but you're going to prove it by showing it that opposite sides are congruent. So you're going to do some sort of math here. And then you summarize the meaning of your math and the punchline, which is it's a parallelogram because right here, this page you're going to do on your own. Pause the video, then restart. Pause the video. Let's see here. If you're trying to show opposite sides are congruent, you're using the distance equation. So if you did that correctly, you found that AB and DC were both root 20. And you found going this way, AD and BC are root 58. So here you would write something like AB equals root 20, DC equals root 20, AD root 58, BC equals root 58. Math, meaning so AB is congruent to DC, AD is congruent to BC. Punchline. ABCD is a parallelogram because opposite sides are congruent. Take a minute and review what you have learned in this lesson. And again, the main component of the lesson of this is the fact that math has meaning.